All right, hey everyone. We're gonna be talking about the double angle formulas today. That's your aim, how to utilize the double angle formulas. Your do now is gonna involve another evaluating, whether the identity is correct here. And then part B is what formula can you come up with based on your answer to part A? That is sine of 2x equals what? Homework is going to be in the OpenStax textbook. It's page 594, numbers 5 and 7, as well as page 595, numbers 34, 37, 55, and 56. And you can ignore this one. This is from the old textbook, so only this part right here, OpenStax. Okay. All right. Well, actually, just to allow you to see it more easily, I'll go to the slide here. Yeah, so here we have 2 times pi over 6, and that equals 2 sine pi over 6 cosine pi over 6, or at least Cauchy thinks that this is true. And if we simplify this, we get pi over 3, right? So 2 times pi over 6, that's pi over 3. And then if you simplify the left-hand side of the equation, you're going to get root 3 over 2, right? Sine is 60 degrees, that's root 3 over 2. And we're going to determine if he's right by evaluating this side, okay? And then part B will come up with a formula. All right, if you need to copy this, please pause the video here. Otherwise, I'll get back to the solution. All right, here we are. So root 3 over 2, right? That's what we had on the left. And this might be equal to, right? That's why I put a question mark here, 2 sine pi over 6 cosine pi over 6. Well, pi over 6 is 30 degrees, right? So sine of pi over 6, sine of 30 is 1/2, and then cosine 30 is root 3 over 2. So we're going to be left with 2 times 1/2. And that's just 1, right? So then we'll be left with root 3 over 2 equals root 3 over 2. So this is true, which means that he was correct. Okay. And then for the formula, sine of 2x, if you look at the first line here, so sine of 2 times an angle, and then you see the same angle appearing on this side, right? So pi over 6, right? Sine of 2 times x equals 2 sine x cosine x. That's our formula actually. So sine of 2x, sine of 2 times an angle is equal to 2 times the sine of the angle times the cosine of the angle. Okay. And we'll see how to derive this in just a sec, but this is our first double angle formula. Before we get to the double angle formulas though, I'm going to show you a quick slide of the addition and subtraction formulas from last time. So I have that here, but let me show you the slide. Okay, so here are the addition and subtraction formulas. So we have sine, cosine, and tangent, right? And you don't have to copy these down. These are the same formulas from last time, but just as a reminder, we're going to be using these throughout today's lesson. So yeah, just for reference, here they are. Keep them in your memory. Okay, and then I also write here why in italicized, right? So why are we reviewing this? It's because the double angle formulas, which we'll look at today, can be derived from these addition formulas. Okay, so technically only the first of the pairs, right? So we have this one. We're going to use to derive the cosine double angle formula, and this one we'll use to derive the tangent double angle formula. Okay. All right, but yeah, let me get to the examples. So the first example or exercise is derive the formula for sine 2x using the addition formula for sine. Okay, so sine of 2x, we can see this as sine of x plus x, right? Because x plus x is 2x. And then from here, we know that sine of an angle plus an angle is equal to sine cosine plus cosine sine. Okay, so we get sine x cosine x plus cosine x sine x. We can, by the commutative property, right? Multiplication is commutative, which means you can switch the order, right? Like 2 times 3 is the same thing as 3 times 2, right? So we're going to do that same thing here. Cosine x times sine x is equal to sine x cosine x, okay? And then here we can factor. So we have sine x cosine x plus sine x cosine x, which you can see as 2 sine x cosine x, right? It's like 2 of the same variable. So like kind of like y plus y is 2y. Or you can see that as, I factored. So I factored out sine x cosine x. And then here we have parentheses 1 plus 1, right? So I factor out this from this and that. And then as you can see, if you distribute this part, right? If you distribute this times this, plus this times that, you get that, right? So you can see it like that too. But either way, you get sine x cosine x times 2, or how we normally see the double angle formula for sine is 2 sine x cosine x. All right, and then next we're going to derive the three formulas for cosine 2x using the addition formula for cosine. Okay, so cosine 2x equals cosine x plus x, and that equals, right, so cosine, the addition formula, right, it's cosine cosine minus, right, the sign changes for cosine. So it's cosine cosine minus sine sine. Okay, so we're going to have cosine squared x minus sine squared x. And we're going to use the Pythagorean identity, right? Sine squared x plus cosine squared x equals 1. And we can rewrite this as sine squared x equals 1 minus cosine squared x. Or we can do the other one, right? Cosine squared x equals 1 minus sine squared x. So we can use either of these to rewrite this. So this is the first form of the cosine double angle formula, cosine squared x minus sine squared x. That's why I bolded it. But to get the other two, we're going to use these. Okay, so continuing from this, we get cosine squared x minus, so as we see from here, sine squared x is equal to 1 minus cosine squared x. So we're going to substitute this part into here. Okay, that's what you see here. Okay, so cosine squared x minus that. If you distribute the negative sign, you get cosine squared x minus 1 plus cosine squared x. So we have 2 cosine squared x, right? Because cosine squared x plus cosine squared x. And then we add that minus 1 from the middle. So we're going to end up with 2 cosine squared x minus 1. Okay, so that's your second form of the double angle formula for cosine. And then if we use the other form of the Pythagorean identity, this right? So we have 1 minus sine squared x equals cosine squared x, right? We're going to substitute this into that. Okay, so we have 1 minus sine squared x minus sine squared x, right? And then we'll get 1 minus 2 sine squared x. And this is the third form of the double angle formula for cosine. Okay, so 3 forms for cosine, and then only 1 form for sine, right? So, I mean, the reason why we can write 3 different forms for sine is because we have this Pythagorean identity, right? Because we have sine squared and cosine squared in this first form, right? So we have cosine squared, sine squared. But for the double angle formula for sine, right, we don't have sine squared or cosine squared. So that's why we only have 1 form for sine. Okay. I'll bold that actually. So yeah, just these are the formulas here that we just derived. Okay. You don't need to copy this down now, or the actual formula. So I will copy down the solution. So I guess you would thereby copy the formulas, but I'll show you another slide in just a sec. Okay. All right. So if you need these solutions, please pause the video here. Otherwise, I'll move on. Okay. So yeah, here are the double angle formulas. And then for tangent, we'll derive that in the classwork. Okay. But yeah, those are the exercises that we just did. And then here are the double angle formulas. Okay, so sine 2x equals 2 sine x cosine x. And then here are the 3 for cosine. And then here's the one for tangent, which we didn't derive just yet, but we will in the classwork. It's 2 tan x over 1 minus tan squared x. All right, if you need more time to copy this, please pause the video here. Otherwise, I'll get to the classwork. Okay. All right. Actually, let me show you the worksheet first. So yeah, first problem, as I said, is we're going to derive the formula for tan 2x. And then the other 3 questions are just applications, or not applications per se, because it's not like a physical example like physics or chemistry or anything like that, but just, you know, we're going to be using the double angle formulas in the other 3 questions. Okay. All right. But yeah, those are the questions. Let's solve them. All right. Question number 1. Let me zoom in just a bit. All right. So tan 2x, we can see that as tan of x plus x. Right. And using the addition formula for tangent, right, that's tan plus tan over 1 minus the product. That's tan x plus tan x over 1 minus tan x times tan x. And that simplifies to 2 tan x over 1 minus tan squared x. Okay, all right, pretty simple, right? Just That's how we got it. 2 easy steps, right? That's it. Yeah, that's your addition formula for tangent. And then for question 2, we're given cosine x equals -2/3. We're given that the angle is in quadrant 2, and we're tasked to find cosine 2x and sine 2x. Okay, so cosine 2x, since we're given cosine, at this point you can choose one of the three. But just to solve immediately, right, directly, right, we can use the cosine form, right, the form that only involves cosine. So we have 2 cosine squared x minus 1, and then plug that in, right, -2/3, right, 2 times -2/3 squared minus 1. -2/3 squared is 4/9. So we get 2 times 4/9 minus 1. So we get 8/9 minus 1. And then your final answer here will be -1/9. Okay, so that's cosine 2x. And then for sine 2x, we're going to use, well, you only have one option for sine, right? So we have 2 sine x cosine x. We need to find sine first. Okay, so to use the formula to use the formula sine 2x, 2 sine x cosine x, we need to find sine first. Okay, so we're going to do that by using the Pythagorean identity. Okay, which is true for any angle. Okay, it's called an identity because it's true for all angles. Okay, so sine squared x plus cosine squared x is 1, right? And then rewriting that, we get sine squared x equals 1 minus cosine squared x. And sine x, taking the square root of both sides, we get sine x equals the positive root of 1, the square root of 1 minus cosine squared x. Okay, and we know that's positive because it's in quadrant 2. Okay, positive because, again, we know that's in quadrant 2, that's given. And sine is positive in quadrant 2. All right, so then from there we just plug in, we get cosine squared x. Cosine squared x is 4/9, right? So 1 minus that in parentheses squared is positive 4/9, right? So be careful with the minus sign. So 1 minus positive 4/9, we'll end up with 5/9. And then square root of that is square root of 5 over 3. So be careful there. That's just sine x, okay? But we need to find sine 2x. So sine 2x, we're going to use that formula, right? 2 sine x cosine x. Sine x we just found, which is root 5 over 3, right? And then cosine x we were given, right? That's -2/3. So we're going to plug that in. So we get 2 times this times that. We get -4 root 5 in the numerator, and then in the denominator we get 9. So your final answer for that is -4 root 5 over 9. Okay, so these are 2 answers for question 2. All right, if you need to copy these solutions, please pause the video here. Otherwise, I'll be moving on to the latter 2 questions. All right, question 3. I know this seems intimidating, but nothing we can't handle because we are Bronx Science. All right, so cosine 3 theta, cosine, we can see that as, 3 theta we can see as 2 theta plus theta. Okay, and then from there we'll use the addition formula. Okay, so cosine of an angle plus an angle is cosine of the angle times the cosine of the angle minus sine of the angle times sine of the other angle. So we get cosine 2 theta cosine theta minus sine 2 theta sine theta. And then cosine 2 theta, right, we're going to use the double angle formula. And since we're writing in terms of cosine here, all right, let's use the cosine form of the formula. Okay, so we get 2 cosine squared theta minus 1 to replace that times cosine theta minus, and then sine 2 theta, right, we use the double angle formula, 2 sine theta cosine theta times sine theta. And then from here we multiply. Okay, so distribute this, we get 2 cosine squared theta times cosine theta is 2 cosine cubed theta. And then 1 times that is cosine theta. So we get that for this. And then for this, we get minus 2 sine squared theta cosine theta, right? So this is just this times that, which is that. Okay. All right. From there, we're going to use the Pythagorean identity, right? So sine squared theta. And we can see that as 1 minus cosine squared theta. Okay. So we replace this with that. This part right here. Right. Okay. And then everything else is the same. And again, the purpose of that is because we're writing everything in terms of cosine. Okay, so yeah, use that Pythagorean identity. We're going to get 2 cosine cubed theta minus cosine theta minus. So here I distributed, I multiplied this with that. So we get cosine theta times 1 is cosine theta. then cosine squared theta times cosine theta is cosine cubed theta. Okay, so I just multiply that. And then in the next step, I distribute the 2. So we get negative 2 cosine theta plus 2 cosine cubed theta. Okay, so we get that. And then just combine like terms. So we get 2 cosine cubed theta plus another 2 cosine cubed theta is 4 cosine cubed theta. And then minus cosine theta minus 2 cosine theta is minus 3 cosine theta. So that'll be your final answer right there. Okay, so moving on to question 4. On the homework tonight, by the way, you're going to have some of these questions like prove an identity. And we're going to use, the identities and the formulas we know to, simplify. Okay, so that's what we'll do here. So we have cosine 2x plus 1 over 2 cosine to the 4th x equals, and we have to show that this is equal to 1 plus tan squared x. Okay, and we're going to do that by simplifying the LHS. LHS, by the way, that stands for left-hand side of the equation. Okay, so we'll simplify this. Okay, all right. So 2 cosine squared x minus 1. That's just the double angle formula for cosine again, right? This cosine 2x is equal to that, right? And then the plus 1 stays the same. And then, as you can see, minus 1 plus 1, that's 0. And then so we'll be left with 2 cosine squared x in the numerator. The 2 divides out here. So we get 1 over cosine to the square, cosine squared x. So cosine squared x will be in the denominator. And then we know we should recognize this as secant, right? Because secant is 1 over cosine. So this will be secant squared x, right? Because this cosine is being squared. Okay, so secant squared x. And then if you remember the mnemonic, right, I tan by the c. So 1 plus tan squared x equals secant x. Oh, sorry, secant squared x, right? 1 plus tan squared x equals secant squared x, right? I tan by the c. You can recognize this as 1 plus tan squared x. Okay, and that's what we have on the right. So we thereby prove the identity. Okay, so if you need these solutions, please pause the video here for this and that. Okay. But yeah, that is all for today. Make sure you submit your homework per usual, and I'll see you all in the synchronous Zoom session. Have a great day. Take care.